this video to you then.
All right, sounds good.
This will just be after. All right, bye.
Thanks.
All right. Let's take 16. All right, I found the thing right here. You see my page?
Hey, Ellie, go. Go, girls, come on.
So the z-score for proportion is value minus mean or standard deviation. Standard deviation of p hat is the square root of p times 1 minus p over n. You guys there?
Yeah, I get this.
Okay, I do my homework, okay? Come in here right now. Okay. Sorry about that. Okay.
It's cool.
The p hat equals 0.427. P equals 0.45. So to get the standard deviation of p hat,
it's p times 1 minus p over n is the standard deviation.
So it's 0.45 parentheses 1 minus 0.45 all over the population, which is how many? 750?
Yeah.
Okay.
Calculate that for us. We'll just go with your answer.
Standard deviation that I have is 0.018.
Are you doing p times 1 minus p over n and all square rooted?
I just put it into the Excel app.
Yeah, it's 0.018. Yep.
All right. Well, you're using efficient technology, Spencer.
Yes, I don't know.
All right. So what is it again?
So
0.718.
That's just the standard deviation.
So the standard deviation is 0.018. That's, yeah, you're right. That's just a standard deviation.
Yeah, go back to that other page real quick, Brooks.
Yeah, right here. So this is what we're looking at.
I can't see it. Read the formula to me.
All right.
Oh, okay.
So there's two formulas. The standard deviation formula is square root of p times 1 minus p over n, and the z-score formula is value minus mean over standard deviation.
Okay.
So let me see if they show it later.
So the value is. So
all right, here's a better picture right down here. P hat minus p over square root of p times 1 minus p over n.
Okay, so 0.427 minus 0.45. Let's let me write all that out real quick.
Yeah, no, it's cool. This is gonna be on the test, so.
Hat minus p over the square root of, or just the standard deviation, in other words. Okay.
Yeah, and the standard deviation only uses p, not p hat.
4 to 0.427 minus 0.45 divided by.
I'm just gonna let you know what I have.
Yeah, go ahead.
I just went through the Excel, and the z-score that I got was negative 1.284, and so the probability of it being less than, right?
Yeah.
So the probability, I put it in the probability app, and I got 0.099, which would be 0.100.
This goes 0.99. I've gotten questions wrong around like that.
Okay, but I don't know what you're gonna get.
What is it asking?
It's asking for the probability. So I think Spencer's got it.
Oh, I sure hope so.
I'm definitely gonna need to do some serious writing of notes before this test.
Yeah.
I suspect there will probably only be a few questions about Unit 4, and majority will be other units. Because Unit 4 is fairly straightforward. Camden, you still with us? I think he's frozen.
Yeah, darn. Okay.
I'm going with your score. We'll keep going and we'll come back to stuff.
So on the next one, did you get the next one?
Give me one second. I'm pulling up right now. So 24.
They decided to go with 0.091, and I'm not gonna lie, I don't really understand why, but
yeah, no, give me 1 sec to read this.
Hey guys, sorry about that. On that last one, did you? Oh, shoot.
the last one. What was your question, Camden?
I got 0.1001 because it's asking for what is the likelihood of it being less.
You know what, you're right. That's pretty much the same exact one that we have.
Yeah.
We decided not to round, so we got 0.099, which technically, if you round, it would be 0.100.
I see.
Yeah, I think there's a slight bit of discrepancy based on how he did it. Because he used the Excel, which is a little more exact, and you did it by hand. But either way, I think there's going to be a discrepancy, an error ratio that I will accept.
Okay. So if we're wrong on 0.099, then it's obviously going to be 0.100.
Yeah. Sure. I suspect with all of these, when they're inputting their answers by hand, they have a small margin of error they accept.
I think so too.
All right, let's see if we can figure out 24. I'll be honest, I don't get this either.
Okay, suppose you're testing the null hypothesis. Oh wait, we already did that one. Sorry.
Yeah, no, I didn't do it yet. I was working together.
Yeah. So essentially, what Davis and I had thought was it was 0.091. So
could you explain why?
The reason. Okay, let me read it one more time to make sure I understand. Okay. You have calculated to be z area to divide by z is the p-value. Wait a second. So the p is the original value, right? Like that's the mean that we already know, right?
Yeah, the p is the mean is 0.62. All right, well, it's different numbers, but yeah, that's the mean. We're trying to see if it's not the mean. So I don't know if just looking to the area to the right is correct.
Yeah, now I'm starting to doubt that.
I think it may be you. I mean, I would suspect you. I don't know what you do, but you need to do something to those numbers.
Is there some type of calculation that we need to do then?
That's what I don't know what it is, but I think we do. I just.
Okay, let's think about this.
All right, let me pull it back up.
Yeah, I have no clue on that one. Ugh.
Portion.
Which chapter are you in, Brooke?
I'm on 16. I don't know if that's right though. I know it's going to be proportions because it's a p-test.
Right.
Let me see. All right. Was either 16, 17, or 18?
Say that one more time.
Well, the chapter is going to be in 16, 17, or 18. And it's likely 16 or 17. If you guys are you guys good on time then?
Yeah, I'm good.
Yeah, I'm good till 6.
Yeah, well, hopefully it doesn't take that long. I got other stuff to do.
Yeah.
Jeez. Hey Spencer,
Sorry, what was that?
how did you calculate that on Excel the last time?
I went to the paired. Let's see here.
Because I'm thinking,
Last time, let me get to it real quick. Sorry.
that's okay. Because I'm thinking if you can just calculate that again, and you'll be able to see what the p-value is potentially, and then we can.
Oh. Okay, yeah. So I went to one proportions on categorical data analysis Excel.
Okay.
That's a failure testing 0.62. Hmm. Testing is 1.334.
Yeah, let's work on this real quick. Don't go back to the other one.
It won't work because I don't have the sample nor the mean.
Yeah. All right.
It's one proportion, right?
Yeah.
Yeah.
All right. Let me share screen this. Just take a look real quick and let me know if you think that looks correct.
I would say okay, so your z-score on here is negative 0.1284, but the z-score on the question is 1.334.
Oh, I'm doing 23. Or are we doing 24? Okay, sorry. I was confused on what we're doing.
Oh, they were doing 24.
Yeah, sorry. I didn't understand that. Let me change this. Yeah, you're right. You can't do it on 24 if you don't have the data.
Yeah.
Sorry, I got confused.
So I'd almost say let's just stick with one answer and hopefully you can guess lucky. I don't know. It'd be nice to know what it is, but I think we can be stuck on this question for hours.
Yeah.
Let's move on and pick an answer you feel comfortable with. Move on, and if we have time, we'll go back to it.
Okay.
So don't leave it blank, of course, but just pick something you feel comfortable with. Move on. If we have time, we'll go back. All right. Suppose you're a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. Is it known that the distribution fertility level is Cocker Spaniels normal? How many measurements must you have in order to sampling as far as normal? That's easy. This is confidence interview of true mean, so it's A.
Oh, really? Okay.
Yeah, because we're talking about unit 2, so quantitative data.
Gotcha. Okay.
And that's the law of large numbers. Oh, no, wait, is that it? Yeah.
Yeah, law of large numbers.
You know they're going to test me on that.
Yeah, they always do.
All right. So want to read 26?
So you put A on that one, right? Right, Brooks?
What?
You put
oh, yeah, I did.
Okay, 26 says, a study is planned to compare a proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken, and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform the hypothesis test? Why? So how many are there in total?
I think it's B, but feel free to correct me. Oh. Try plugging it into the test.
I think it's D.
Yeah, I just realized that.
Because with the women portion, you do the math, 56 times 1 minus 0.84, you get 8.96.
Yeah.
Yeah, no, I just realized that. So we're good with D then?
Yeah, that looks good. So just in the future, for future referencing on this test, so just one, at least one. Oh, I see. It's no, because at least one. Yeah, because it's less than 10.
Yeah, they both have to be either N P is greater than 10 or N times 1 minus P is greater than 10.
Okay. So
they can be equal to 2, but yes, both of them have to be accurate.
Yeah, so B is one of the tests as well, though. It has to be the NP is more than 10 and N times 1 minus P.
Yes, it is both, and that's where they tried to trick you.
Okay, sounds good. Next one says the study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for the analysis? So the mean is not equal to 0.
Yeah, I think it's B. It's difference.
Yeah, the mean difference is not equal to 0. Does that seem right to you, Spencer?
Sure.
Let me share screen this again. Sorry.
Which test are we using? Are we using?
I believe it's different paired t-test because they're looking for a difference between the two.
Okay. Yep, you're right. Correct.
All right. I'll read 28. Weight Watchers want to predict how much weight a client will lose if they follow a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into two groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise group, they used linear regression for sin compliance with the exercise program as explanatory variable and pounds lost in 3 months as the response variable. One of his clients told that his residual was 5.5 pounds. What does this mean?
I don't get this one.
I think it's B.
Can you explain that one for me?
Yeah. So, and feel free to come in too, Camden. From my opinion, residuals are the difference between observed and predicted data. So if your predicted data, the predicted data is in a perfect world, which we're not. So residuals exist in samples because there are discrepancies that are related to factors we don't know about. And so basically we have a residual chart because if all these factors that cause these numbers not be perfect, if they have a normal distribution, then that means that we can consider our data correct. A little more info that you need, but basically point is residuals are the difference between the observed value and the predicted value.
Okay.
Yeah,
So are you saying that it's B?
I think it's B.
His actual weight loss was 5.5 pounds higher than his predicted weight loss.
I'm gonna look it up real quick.
Yeah, go ahead.
Okay.
The residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line as an equation. So it's y minus y hat. So his residual is 5 pounds. So his was 5 pounds more. Yeah.
I think it's B. Go ahead.
Yeah, it's B.
Well, all right.
All right, 29. Go ahead.
Is that the observation minus what it should have been or the predicted amount. So in this case, if he's saying that he has a residual of a positive 5.5, then that means that he actually lost more than what he was.
Yeah, the wording is kind of confusing on this. The word of choice, word choice of higher would be poor, and you wouldn't do an actual test. But I think that, yeah, it's
okay.
Because it's loss. Loss is higher, which means it'd be more loss. Yeah, it's just weird wording.
Yeah.
All right, you ready for 29?
Yep.
For the setting of previous question, the B1 regression line was 5 pounds. Interpret the statistic. That's
I think it's C because B1 is the slope. Every 1%, 5 pounds are lost.
Yeah, I agree. Oh, this question.
Oh, crap.
You know what I'm talking about, right?
Yeah, residual plot.
This is the one we get our last one.
Check all that. Why? Okay.
All right, I'm going to bring up the book.
Yeah, that's what I'm doing. So, linear relationship. Normal error term.
You got 23 up?
Yeah.
It's like number 3 checking requirements.
Box. You have to do like more.
All right. There's a linear relationship. Check. Let's see. The error term E is normally distributed. All right, check. Variance of E is constant. I think that's what it was. Residuals are E. Okay, yeah, that's normally distributed. Check. X are fixed and without error. Check. Observation independent. So it's everyone. You guys still there?
Yeah. Okay.
All right, I'm gonna move on. I think Camden froze up again. Okay, next 12 questions.
So pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the prices. Seats on a flight do not sell well, and may discount the tickets or even cancel the flight. Ali Heinrich of Billiardo Studios wanted to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe. Velocities.com recorded the lowest published fares for 90 nonstop midweek flights in 90 days in advance. And then found the lowest published price for the same destination against 14 days in advance. Prices in US dollars are given in the file, blah, 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 blah. Notice that for some destinations, flights are not available. Compute the sample correlation coefficient, the price of tickets 14 days before compared with the price of tickets 90 days before. The variance is accurate 3 decimals. All right, so we just go back to what we did earlier.
Yeah.
And I have 0.764.
Sure, let's go with that.
And that's just the R, right? Like,
yeah.
Okay.
That's just a lot of stuff.
Mine might be wrong though, because mine is taking into consideration the zeros.
Oh, okay, yeah. Give me 1 sec for this.
One that you and Davis agreed on.
That's right.
Dang it.
Which one did you guys put for 30?
Yeah, give me 1 sec. All of them.
Are you sure about the residuals one? Because it's not that they're supposed to be normally distributed, I thought. I think it's just...
Yeah, number 2, the error term E is normally distributed. That is the residual.
Oh, okay.
It says up here with it, the random variable we denote, there are some type of randomness in their values of Y. We call this an error term. That is the residual.
Okay, and then the variance of the error term is constant.
Yeah, I'm pretty sure it's all of them.
Okay.
We're going to need your help for the next one, though.
Okay. Let me read through it really
Remind me what's a correlation coefficient?
Okay. I thought that was the R score, or not R squared, but just R.
Yeah, the R. Yep.
Where are you getting it on your test?
It's on the quantitative interference procedures Excel.
Yeah, I'm on there. I'm just not seeing it though.
So, are you underneath linear regression?
Oh, okay. Sorry, my bad.
Okay.
I thought we were doing the same one, but we were not. Give me 1 sec to input this in.
Okay. I still don't know how to get the zeros out of there.
All right. So my R is 0.780.
Yeah, I say go with that one.
Yep, I got that too just now. 0.780.
All right, that's fine. All right. Okay, scatter plot. I'm getting B.
Yep. Say.
You agree, Camden?
Linear with fairly strong positive association. Yeah, that's the only option I would put. Yeah.
Compute the y and slope. Rationalize based on. All right. Y-intercept. This remind me, which one are we using? Are we?
I would say we're using, if you go down below model summary and go to like the unstandardized coefficients.
Yeah.
But like y-intercept, which is model has zero, next to it, right next to it, it should have like -8 point something. Is that what you have underneath yours?
All right, give me 1 sec. You're cutting out on me.
Okay, so I'll show you on mine. Where
okay, yeah, just share screen. That works.
Okay. All right, can you see my screen?
Yeah.
So I would say the y-intercept right here. You go to this side, and it has the B. I would say that's the number we're looking for.
Is that your data correct?
I don't think my data is correct though. So look on
All
your.
right, I got 115.64.
Right here.
Yeah, for y-intercept.
Oh, okay.
It makes sense though because you're talking about airline prices. They're not going to be below that.
Gotcha.
Yeah, the airline prices are ridiculous, and if you're looking at, it's not going to be 0 or anywhere below negative. I don't think that.
Okay. So yeah, I'll just go ahead and
all right, yeah, I'll input them in. Give me 1 second. So, give me 1 second. I'll share screen this. Am I okay? I am. Slope is point. You see this?
Yep.
All right. I'm gonna. Let me know when you're ready.
I'm ready. Yeah.
Okay.
Just show us the Excel. Like, just show us the numbers.
Yeah, yeah. Give me 1 sec. All right. That look okay?
Yeah. Well, my numbers are so messed up.
You might consider re-downloading the sheet because maybe there's an error on how this functioned.
What did you change on there to get this?
What was the question, Camden?
What did you change? Like, first, what did you put into your Excel?
Me? Oh, this is a linear regression.
Yeah. So what did you enter in for this?
Yeah. So it's the same data we had on the direct flight costs.
Yeah.
So 90 is your explanatory variable. That's what you're using to predict. And 14 is your predicted variable because that's what you're predicting. And so you can put the 90 days into X and the Y, you put the 14 days, and that's what I got.
Aren't you missing the data on the line 15 on your Excel?
Yeah, it was a 0 because some of the ticket prices were not available on Travelocity.
So that's why there's no explanatory variable there. That residual is that's correct.
My question to you, Brooke, did you just like?
Oh, how do I get it to do that?
Yeah.
I did. I directly copied and pasted the data from the sheet.
That's all you did, and you just pasted it?
Yeah, no, it fixed it. It did that itself. I don't know. I can't tell you more than that.
Oh, okay.
Again, I would recommend, I know I'm going to do this too, before taking a test, get fresh copies of the Excels.
Yeah.
This is smart. All right.
Correct. Next one, 35.
I'm gonna take the tie, so I'm gonna take it. This is 16 days.
Oh, I see.
All right. So what you're gonna do for this one is input your X as 200,090. I think.
Well, I don't know. Is it 200,000 or just $200.90?
Yeah, I did that wrong. Oh, yeah, that has to be a period. I think that's a mistake because there's no way a flight is that expensive. Yeah, it is a comma there, but I think that's a wrong. Okay, yeah.
Well,
I got two. Go ahead.
Isn't it saying on the same flight costing $200 90 days before? So the 90 is referring to how many days?
Okay, yeah, all right. That's my bad.
Oh, good job.
Thank you, Camden, for. All right, so I'm getting 240.979. So round of 1, 240.9. I think they would also accept 241 too.
So the answer is 179.549.
What?
What was the answer again? Sorry.
All right, yeah, no, it's fine. I'm going 241 because it says round to 1 decimal, and that 1 decimal is going to round up to 241. So let me share screen this again. I constantly flipping stuff.
$241.
All right, ready to move on? All right. I'm going to keep filling in the data, Spencer, and then come back to it when you get a chance.
Okay.
Because I do think yours is wrong. All right. Lower bound. It's slope. Okay, slope, lower bound. 1.518. Lower bound. Error is. All right, you ready?
Sorry, guys. I don't know what the deal is in this stupid internet.
Where you guys left off on?
36.
Yeah.
30 what?
36.
Okay. So this field is in. This is what I got off my data. So 36 is 0.518. 37 is 0.735. And 38 is 0.1085.
And then what'd you get on 35?
35, 241.0. It rounded up.
Okay. And the slope on 34 you just got 67.
Yeah. So all this is pulled from my data.
Okay.
And I'm comfortable with my data, so I think that's okay. All right. Next, for question to conduct a hypothesis test to determine if the slope of true linear regression is not equal to 0.
D on that one. Just be careful with the beta symbol because it's not It's not the lowercase b. It's the Greek beta symbol, which is D.
So which one is it?
So it's the very last option.
Okay, yeah. I was getting confused too. Okay, that makes sense. All right, so this is back to this data. So my test statistic slope is 11.5110.
Do it.
That makes sense.
Yep.
What's the p-value?
Okay, I put them in wrong backwards. Give me 1 sec. So p-value is 0.000.
Okay. Almost there.
Yes.
0.0.
I think it's C on this next one.
Wait, did you put 11.510 for 40?
Yeah, I don't know if you noticed, but because what you're looking for is the slope 0 or not. So your test statistic is going to be really big because it's almost never 0, and so unless that makes sense.
See. Yeah,
because it was a little confusing when we first started doing this, but then I realized why all our numbers are coming out as E's. It's because you are testing whether it's 0 or not, and when it's not 0, it's going to be really big.
Yeah, okay. I just got it. Yeah.
Yeah, it's a logical thing. All right, let's see if we can finish up, and then I gotta go. All right. And in the United States, mothers who live in poverty generally have babies with lower birth rate than those who do not live in poverty. The mean birth rate for babies born in the U.S., mothers living in poverty is approximately 2,800 grams. CDC carries the study determined the effectiveness of new prenatal care in reducing the number of low birth rate babies born. For the study, 30 mothers, all from live in poverty, participated in the program is recorded. Which hypothesis is most appropriate for the study?
Is that a paired sample t-test? No.
It's one sample.
Did you guys already do 42 or what?
42?
Yeah.
Didn't we say it was C? Or we skipped that? Maybe I skipped that.
Yeah. Yep.
All right. So I'm thinking,
Isn't this a paired sample? Or maybe not.
well, see, the difference between the T and the Z test is, remind me of this again. That's what it was testing.
The Z test it gives you the standard deviation, but T test is when you don't have a standard deviation.
Yes, that's right. Yeah, it's going to be a T test.
Oh.
Because it's one sample, but they don't have a standard deviation because it's something they can't test. So I think it's a T test.
It's not paired because they're not dependent on one another. So.
And this is mean, so it can't be proportional or anything like that.
Oh, you're right. Right.
These ones are hard because like there's so many options.
Yeah, it's everything. Yeah, it's like pretty much everything we've done. So.
Yeah. All right. So I want to read 44.
Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure on the gasoline made by the refiners is 0.03. Which hypothesis test? So it's going to be the one.
Yeah, that's easy. 45. The attorney wants to know what the percentage of Walmart employees in Nevada who are over 40.
What was 44 again?
One sample Z test.
Oh, okay.
So I think this one is going to be a test of one proportion.
Me too.
All right, 46.
Marriage counselor conducted a study of couples, categorizing each of the couples as competitive or non-competitive. The counselor wanted to see whether the percentage of couples who said divorce was the same. Would this be the Chi?
No, Chi is testing independence. So this would, I believe this is tested two proportions.
Okay. Yeah.
Because the Chi test, all testing is whether they're not, what you're looking at is independent or dependent. That's it.
Okay.
That one's kind of confusing. 47, a business marketing firm specializes in radio advertising to help to show there's a linear relationship between sales and amount of stuff. That's obvious regression.
Yeah.
All right, let's double check, make sure you got everything inputted in.
Yeah, I just need the 1 through 18 if you don't mind when you're finished.
Yeah, let me go to the beginning and I'll check, make sure I have stuff too.
Okay. Okay, so number 1, what is that? I'm just checking. Number 2.
2 is C.
Okay, 3 is C. 4 is C.
4 is C as well.
5 is 2.5.
Yeah, 5 is 2.5. 6 is 146.8.
Okay.
7 is skewed right.
Okay.
Let's see. 8 is 2.236.
Okay.
9 is 0.991.
Okay.
10 is B, probability committee attack 1 error.
Okay.
11 is the last one.
Okay.
12 is the second one, distribution of sample means normal because the data is normal.
Okay.
13 is 0.019.
Okay.
14 is dependent sampling, and it's the first one. He needs to select couples for a sample, so yeah.
Okay.
15 is 0.096.
Okay.
16 is A.
Okay.
17 is C.
18 is.
Sorry, I was waiting for your confirmation.
Yep.
18 is C as well. 19 is the last one, D. 20 is 13.
He's gone.
Say it again.
He got logged out.
Oh, okay.
Oh man, this is a rough one. Oh.
I'm a little scared about this test now.
Oh man, I'm still not ready for it.
They're having a review.
Over to my phone.
Okay, where are you on?
Yeah, that should be it for me.
Okay, I'm just gonna double check I have an answer for everything. Then I'll turn it in and I'll just leave it with what I get. I'm not gonna do this again.
Sounds good.
All right, I feel comfortable about all this. All right, 3 is wrong. I thought that was wrong. So it is not an experiment. I think it's an observed field study.
Like A or B?
I think it'd be
Yeah.
A. Students have no control over which cereals are. Or no.
It's B, I think. Yeah, Davis really thought it was an experiment, but I'm thinking the experiment you have to have some sort of like control group and stuff. It's cool, but I think it's probably B then. That's the first one. All right. So we are missing one question on 11. It's a collect all.
So we had done all of them, right?
No, 11 is a different one. 11 we didn't recognize it as a mark all.
I see.
So we know the last one's correct. Just let me see.
I wonder if it is also C.
Yeah, let me see.
I'm thinking so.
Yeah, it's probably C. Let me keep looking to see if I got anything else wrong. All right, 19. Go to 19. That's also.
Yeah. Oh, that's a sticking question.
Yeah, we're not understanding. We'll need to. We are individually. We need to go and double check that stuff.
I agree.
When we're done seeing all the ones we got wrong, I can see it a second time, and then we can see.
All right. 20. I think it's 12.5. We had done 13 because we saw it had to be an actual number, but I think it's 12.5.
Okay.
And if you guys can make these changes as we go, so I know if I'm not going to submit again, but that's so I know.
Oh, definitely.
24. That's the one we had no clue on. You see what was Camden?
Yep.
24. Yeah, I have no clue on 24. I have to look back up. 25. That's my bad.
So I'm thinking it's gonna be
D.
Let's see.
Well, because it's X.
B.
It's not P. It's sampling distribution, and it. I was sure it was law of odd numbers, but maybe it's B. I mean, I don't know about that one. All right, let me keep looking. All right, you were right, Camden. There is two in our question 30 that are incorrect, so it's not all.
Okay.
So, probably residuals are normally distributed as one of the wrong ones.
The last one I'm thinking is not included either.
Yeah. Well, it says here there are 5 requirements. Error term. See, this is why I was sure it was all of them because I think residual is a throw-off question.
Yeah, I think so too.
Variance of the error term is constant. That is actually correct.
Okay.
Linear relationship. That's obvious.
The observations are independent.
Yeah, it's seeing all 5 of these I thought were up here. Are you looking at my thing? These are the 5 I'm looking at.
Yeah.
So I can't tell you because I was pretty confident with that one. So.
Yeah, that's weird. If you go down on that same page, Brooks, go all the way down. There'll be like this peach colored box that kind of goes into a little bit more.
Yeah, give me 1 sec.
Explanation.
All right. Let me look at this. Okay, I think here's the problem is what they're testing. This is what we didn't read the first part. Scatter plot, residual plot, Q plot. Which 5 assumptions are we being checked? So we just read the question wrong. So linear relationship, check. Normal error term, check. And constant variable. It's just those 3 because those are only checking with those plots.
So it's
one more time.
All right, so they are not asking what are the requirements for all of it. They're asking when you're using scatter plot, residual plot, QZ plot, which assumptions are you checking?
Okay.
So we just misread the question. So it won't change on here, but the ones we're looking for are constant residuals are normally series correct. That is not being checked. Observation are independent right here. So it's all of them except for C and E.
Okay.
Because linear relationships being checked with scatter plot and residual plot, normal error terms being checked with QC plot, and constant variables checked with residual plot. The other 2 cannot be directly checked.
I see.
So go ahead and put those in and let me know what you get. I do want to see if we can fix some of these errors.
Okay.
We keep going down. I mean, it looks good, to be honest. Wow, it's not bad. So 41.4 out of 47 is an 88. Let's see if we can fix some of that, mostly for my sake, but I'm happy with that.
Okay. So
which ones
are the only ones that you got wrong then?
Yeah, I only missed 6.4 points of a question. I mean, out of 47, we only missed not even 6, like 5.6 points. It's really good.
19.
I'll be happy with E on this test.
19.
So 30, we already corrected, correct?
All right, I'm going to do the corrections right now, and I'll let you know what we get.
All right.
Okay.
All right, with 24, I'm going to select A, 0.046.
Yeah, we have no clue on that one. I'll have to ask it.
5, I'm going to go with B, N is equal or greater than 10.
Yeah, that sounds good to me.
Okay. And then 30.
It's A, B, and D.
A, B, and D. All right.
And I'm pretty confident on that one. I just misread the question last time.
So now submit. I just want to see my. I guess we gotta share my screen, huh?
Yeah, you should share your screen. I'll stop mine.
Okay. Is it sharing?
Yes.
Submitting the quiz.
This.
Right. So 3 is right. E.
Yeah.
It is B.
Yeah, it
Yep.
is B on 3, I think.
And 11 is and E.
All right, so we got that right.
11 is which one?
I got 15 wrong. Why do I have 15 wrong? Oh, crap.
Let me see what my 15 is. My 15 is correct. It's 0.096.
Oh, point.
You got that 0 in the wrong place.
0.096. Okay. All right, and then
Keep going down, please. All right, so we're doing 20 wrong for some reason.
Yeah. Okay. The next one. Okay, that is not 0.046.
Yeah.
34?
25 is not n is equal to or greater than 10.
Yeah, no, I think you may be correct, Camden. Maybe one of the NP ones.
So 25. Yeah.
Well, maybe it's. Go ahead.
I'm thinking it's 1, 2, 3, 4. The fourth one here, the D.
See, that's what I'm not sure because I don't know if we're talking about. We're talking about. Stay there for just 1 sec, Spencer.
Yeah.
I'm not sure because the reason I'm hesitant to put the p-value is because I think we're looking at quantitative data. Because X bar. So in my opinion,
But think about this.
oh, we
People
are so
talking-
stupid. Read the question carefully. I don't know. I didn't notice this. Look at it. Says what?
Any n will do because it's normal.
Yeah, I know. Man, we bombed that one.
So it would be NP, right?
No, it's the last one. Any n will do because it is known that the distribution for Pythagoras is normal. We completely missed that.
Oh. All right, I'll keep going through. Oh, for the love, 30 is still not right. It's not A, B, and just B.
Let me double check this. My bad. Yeah, I misread this. So it is going to. Have you submitted yet, Camden?
No.
All right, let me give you a better one. It is going to be variance because you're checking constant variance, you're checking linear relationship, and checking normal error terms.
Okay.
So it's A, D, and E, and I hope that's right. Otherwise, I'm completely clueless.
A, D, and E.
Yeah. Because I'm looking at this, I keep misreading it. You're looking at requirement, linear relationship, scatter plot, normal error term, QQ plot, constant variable residual plot.
Okay.
I think that I am pretty confident this time. I'm sorry about that.
No, that's okay. I'll try that one next time.
Go for Spencer. 1 sec. We know 25 is the last one. You got that, Camden?
25. Give me 1 second.
Any n will do because it's normally distributed.
Yeah. Yep.
We just completely missed that. 24. It can't be A or B. We've already tested both those. So it's up to you what you want to test.
I would almost try D. I don't know. Any n will do? That can't be the case, right? Because
well, it's normally distributed, so it doesn't matter.
Yeah, it's true.
Because it says here it is known that the distribution of fertility risk is normal. So that was the hit line sinker there. Because if it's normal, it doesn't matter what sample size you use, it's going to be normal.
Okay.
That is the law of large numbers.
On 24, you tried A, Spencer?
Yep, I tried A. The A and B are not correct.
Okay, I'm gonna try C this time.
Yeah, I think it might be C. I don't know why, but
All right, but hold on. I think I got some others wrong.
okay, go ahead.
The accurate one. 33 I got wrong.
Let me see what my 33 is. My 33 is correct. Do you have 115.64?
Ah.
Yeah,
No.
that 4 killed you.
And then I probably have some others wrong. Wait. Why? What do you have for 46?
My 46, give me 1 sec, is correct. It is tested 2 proportions.
Oh, just a few proportions. Wow. Okay.
So I didn't miss that much, and I think I fixed the ones that I missed. So I'm happy. Just go ahead and submit a Camden, and we'll call it good.
All right, Camden.
Okay, it's a moment of truth.
Yeah.
I'm hoping I corrected everything okay. Okay, I missed 1.4 out of 40.
Oh, nice.
That's undoable. What do you miss?
Let's see. Everything. I'm going from the bottom up.
Yeah.
Okay, so 30.
I am so sorry about this.
Hey, don't apologize. You're rocking on that one. You got it.
I'm going to have to ask TA about this because I do not get either. I don't understand what they're asking or is being checked. It's clearly we're getting some of it right,
Yeah.
and I'm pretty sure linear is correct.
And then 20 is wrong.
What the heck?
Let me see what I got by 20. Okay, yeah, we never changed that one.
I put it at 12.5.
Yeah, I had it at 13, and both those are wrong. I think Smith did 12.5. We were supposed to go back and change that again. My bad.
That's okay.
What did you think it was on that one?
Well, I did 13 because Davis thought that it had to be a actual whole number because it was in value.
Oh, well, no.
Which made sense, but it wasn't that. It wasn't 12.5.
I would just go 10.
Well, see, this is where I need to figure out what it is. Oh, man. I forgot how to do this. So you look at the question. It is X. So NP is greater than or equal to 10. So N is what we're looking for. Our P is 4/5. So it's N times 4/5. In order to get that by 10, you time 10 times by 5/4, which is 12.5. So that's, yeah, I don't get why it's not 12.5. Let me try the other one too. Okay. Oh, that's our problem. Hey, you good see I still there?
Yeah.
We're only checking one of the two required equations. We are checking NP is greater than 10. N times 1 minus P has to be 50. Can't be lower than 50. Because 10 divided by 1 divided by parentheses 1 minus 4/5. That let me make sure I got parentheses right there. So give me 1 sec. But I think we just weren't checking the other one.
Yeah.
Yeah, I'm getting 50. I think it's 50 because I think the second one was what was throwing that whole equation off.
Okay, I'll redo it, but I'm missing a lot of the numbers.
Yeah, let's see if we can get 100. Let's start from the beginning. I'll help you through it.
Okay. So
it's
faults. Sorry, my bad.
It's all good.
All right,
Okay.
Go ahead.
Hey, I'm getting the same thing. I'm getting 50, but I actually have to get going. My wife's
All right,
waiting on
I am still recording this, so when me and Spencer get 100, we will send this video to everyone.
Okay, perfect. Thanks so much.
It's not getting uploaded, but check your Gmail later tonight or tomorrow. You should have that. We are meeting tomorrow at 3 my time, 2 your time, so 2 o'clock Mountain Time for the project. I should have it done then. I'll talk with Spencer after you leave about what I need him to do.
Okay, perfect. Thanks so much, you guys.
Yeah, no, thank you.
All right, we'll see ya.
All right, Brooks.
Yep.
So what
number are you on?
I'm on number 5.
Okay. 5 is 2.5.
6.
146.8.
146.8.
So 146.8. Yeah, it's just string. Okay, cool. So you're right, it's correct. 8 is 2.236. Let me share screen.
Okay. Hold on. Oh, come on.
You need me to read them out to you, or you got it?
I think if you read them out to me, it works better, unfortunately.
All right. You ready on 8 or 9?
I am on 8. So 2 point what?
236.
2.236.
Yep. 9 is 0.991.
0.991.
All right. 10 is B.
B. 11 is.
Give me 1 second. So 11 is C and E.
Okay. 12.
12 is B.
13.
13 is 0.019.
0.019.
Yep.
14.
B.
15.
15 is, this is one you missed, 0.096.
0.096. 16.
All right. 16 is A.
17.
C.
18.
18 is also C.
19.
19 is D. Oh, wait. Well, this is wrong.
It's B, right?
Yeah.
19 is B. Okay.
That was my bad.
95% of all 95% confidence intervals can actually contain the true mean. Right?
Yeah. That's
Okay.
it.
21. I got 20 as 50, right? That's the number we're going to go with.
Yes, the 50 is the new one.
Okay. And 21.
Okay, 1 sec. 21 is D.
22.
D as well.
23.
23 is 0.099.
24.
24 is C.
C. 25 is any N will do.
Yeah.
26.
D.
27.
B.
28.
B as well.
29.
C.
30.
30 is this is the one we're not sure. Give me 1 sec.
Okay.
Let's see. I don't know if I changed or not. So normal error term, checking QQ plot residuals.
Gradient scatter plot, residual plot, and QQ plot. What are the 5 assumptions about linear regression?
It has to be linear. The relationship has to be it. Measure normal error term. What is this? Yeah, I think it's A, D, and E, but I'm not 100% sure.
A, D, and E.
Give me 1 more second to double check this.
Last time we did A, D, and E last time, and it was wrong.
Okay, yeah. I think 2 of the 3 we're doing are correct. And
so, would it be possible if 4 out of the 5 are correct, or?
Yeah. Well, here's the deal. We are when the first time we did all 5. It was wrong.
Yes.
Which means, based on my assumption, 2 of them are false. Because I also got a 0.6 when I got all 5 selected.
Okay.
So 2 of them have to. So 2 of them have to be false. We know that linear relationship has to be there. It's just obvious.
Yes.
We've checked in the past. Observation are independent, and I think that's wrong. Known constants. Okay, yeah. So it's not E.
There.
Constant variance. X's are known constants. Constant variance. Give me 1 sec. I need to reread all these questions or all these answers. Okay, let's try that. Alright. Okay, that's what it's referring to. And 3 constant variance. Alright. Here's my guess, Spencer. You here?
Yeah, I'm still here.
Alright. B, D, and E.
B, D, and E. Okay.
That's my final guess. If that's wrong, I don't know.
Yeah. I mean, sorry, I wouldn't do it. I wouldn't try to do it again. Okay, so B, D, and E. That's what. Oh, okay. B, D, and E.
Yep.
All right. Got it. Okay.
You got 30. What do you need now? 31?
What's 31?
0.780.
0.780.
Yep. 32 is B.
32 is B. 33.
All right. 33 is 115.64.
Got it.
34 is 0.627.
0.627.
All right. 35 is 241.0.
241.0.
36 is 0.518.
0.518.
37 is 0.735.
0.735.
Yeah. That's right. 38 is 0.1085.
0.1085.
Yeah.
And
39 is D.
D.
Yep.
Using dog. Okay.
40 is 11.510.
11.510.
All right. 41 is this 0.000.
0.000.
42 is C.
42 is
C is in cat.
Got it. 43.
43 is one sample t-test.
One sample t-test.
44 is one sample z-test.
One sample z-test.
Yes, correct. 45 is test of one proportion.
Test of one proportion.
46 is test of two proportions.
Test of two proportions.
And 47 is linear regression.
Linear regression. All right.
Let's see how we do.
Okay, there we go. Go to submit the quiz. Go submit the quiz. One. Oh, for the love. I got 2 wrong. Oh, whatever. Oh, wow. I got 4 wrong as well.
Let me see what I put for 4.
Okay, it's better than my initial score. Let's see if we got 30 right.
Woo! I feel.
Yeah.
All right. Go ahead.
All right, that's all of them.
Yeah.
This is 100. I mean, obviously, I got.
Yeah. So looking at 4, I have correct. It's not possible to determine, and 2 is also So you misput them in.
Okay, so what is 2? So that Camden and Davis know.
All right. So 2 is the last one. The number of people randomly selected classroom on campus, and 4 is it's not possible to determine about the full data set.
All right, perfect, and that will be 100%.
Yeah, I feel comfortable with that. I wanted to get those taken care of before the test.
Amen. That will help us because now we know.
So one quick thing I'm going to show to you right now. What I need you to do tonight or tomorrow morning for next thing, go into the data collection and input your table of gas prices and zip codes.
Okay.
And then observe the data. I have 2 pages. I don't know how much you need. You need to put all the QQ pods and you need to put the ANOVA chart.
Okay, gotcha.
So you will probably use all 3 of those pages. That's fine. They need to be legible. So make them as big as you can fit on the page without making it distorted.
Gotcha. Okay.
I'm going to talk with Davis. Camden. Sorry, he didn't have time, but I'm going to work with him tomorrow during the meeting and get the hypothesis test put in.
Okay.
And then tonight I'll take care to take action conclusion.
Perfect.
All right. I'm going to stop recording now.